Hello friends, let's have a look at problem 2576. Find the maximum number of marked indices. In this video, we're going to explain a treatment based on the use of quill. Basically, we want to do a simulation. And later, we want to comment that we can use O1 space to solve this problem. First, let's look at the problem statement. So we are given an array called nums, and initially all of the indices are unmarked. So we are allowing to do the following operation. So we can pick two different unmarked indices I and j, such that 2 times nums I is less than or equal to nums j. Then we mark this pair of indices. So we want to find the maximum possible number of marked indices in nums using the above operations any number of times as we like, or as we can. So here are three examples. The last example is special. The output is 0. Because in this one, the smallest number is 6, right? So in order to match this 6, we need at least a number bounded below by 12. But there's no 12 in this nums list, so we return 0. And in the first example, so the output is 2. In other words, we can only mark one pair. So here we can mark 2 and 4, right? Or we can mark 2 and 5. Both are valid, but the results are the same, that is 2. In example 2, the output is 4. So here we can match with 2 and 4, right? Because 4 is twice of 2. And also we can this is not correct. So now let me re-explain. So we can match 2 and 5, right? So basically we have 5 is larger than 2 times 2. So this is one pair. Then we can match 4 and 9 because 9 is larger than 4 times 2. So this gives us 4. However, here we cannot use 2 to match 4. The reason is this one is a valid pair. However, after this marking, we cannot match 5 and 9 because 9 is less than 5 times 2, right? So this is the point to be noticed for this problem. So with that said, let's also look at the constraints. Here, the length of this list can be up to 10 to the power 5. So this number is a decent large number. Basically, it gives us the problem size upper bound. And secondly, the elements in the list is positive and bounded above by a large number. So with that said, we are ready to do the analysis. So as we mentioned at the very beginning, so the treatment will be quill-based simulation, right? So the idea is the following. So we try to pair smaller numbers in the list with larger ones. So we can see naturally, or we can see gridly, or we can see wisely. It's the same thing. So the larger means that the larger number should be at least 2 times small. So here, observation is that if n is the length of this list, and then there are at most n over 2, so n interdivided by 2 matching pairs, right? So if we realize the above idea as observation, so we can use the following steps or algorithm. So first, we can sort the list nums from small to large and retrieve its length. So the reason we do the retrieval of its length is just for convenience. And then step 1, so we're going to use the first half elements to check matching larger ones in the latter half. So we do this specifically as below. So we specify two quills, Q1, Q2. So the Q1 has a length n interdivided by 2. So the remaining one will be in Q2. Then for each element y in Q1, so notice that elements in Q1 is increasing, right? So we're going to pop from Q2 the elements that are not large enough. In other words, it's less than 2 times the current y. So now after this continuous operation, so if Q2 is empty, it means that there's no matching. There's no element in Q2 can match the current y. So we just need to return the counting of the current pair, right? And for sure, if the elements in Q2 cannot match the current y, they cannot match later y's in Q1. So if the Q2 is not empty, then we're going to have the head element Q2 not will be bounded below by 2 times y. Then we could pop it to match y. Then we increment the counting by 2. So here 2 means 1 pair, right? Then step 2, we just return the counting. So with that done, let me also reiterate example 2. So basically we want to show that the above procedure, especially the strategy in step 1, is sound. So let's assume, let's say this is the list in example 2. So if we do the sort, so we're going to have 2, 4, 5, 9. Then this is the Q1, that is 2, 4, and the Q2 is 5, 9. Then for Q1, we try to find the match element in Q2. So the first element 5 matches it, right? So we have 2, 5, a pair. Then we use 4 to match 9, right? Overall result will be 4. So notice that we cannot use 9 to match 2 also, right? So because 5 cannot match 4 later, right? Or also we cannot use 2 to match 4, right? Because 5 and 9 does not match. So this notice basically, this note justifies the soundness of the above procedure. So with that explained, I guess now writing the code is very routine, right? Very straightforward. First, let's do a sort, nums sort, and then I can retrieve the length of this nums. So these 2 lines of code corresponding to step 0, and then we're going to do step 1. So Q1 and Q2. So for Q1, I just use a plain array. That will be enough because you need a linear scan. And for the second one, for the simulation purpose, I'm going to use a deck because here I want to use pop left, right? So this is nums n over 2 onwards. So now let's iterate, right? For y, let's initialize a result to counting the pair of indices, right? So here we count the indices, so each pair we count as 2. Then for y in Q1, so we want to find matching elements in Q2 for this y. So basically, well, Q2 at Q2 0 is less than 2 times y. Then we're going to pop, right? So here we don't, so here we have to do Q2 pop left. So this will return some element, so we can suppress that or just use this one. So this one, this is the while loop. So after we exit this while loop, there are 2 possibilities. First, if not Q2. So in other words, there are no element that can match the y. So we just need to return, right? Return the current result state. Or here, actually, we can do break if we like. The same thing. We are going to break out of the for loop. Otherwise, Q2 is not empty. Then Q2 0 will be bounded below by 2 times y. Then we're going to pop it. Q2 pop left. So this popped element will match this current y. Then we're going to increment this result by 1 pair, that is 2 indices. And then afterwards, so we can return this result. So this code actually forms a solution format to this problem. Let's first do a check. Yeah, it passes one test case. Now let's look at the generic case. Yeah, it passes all the generic cases. So as we mentioned, if we want to not write 2 returns, so we can use break, the same effect here. So now let's check that. Yeah. So with that said, basically that's about it for the solution part for this problem. So here in this solution or in this simulation, we used ON of space. So here the space mainly here. N is the length of the nums. So actually for this problem, we can easily improve up to O1 space. So basically, we can use 2 pointers, right, to track the elements. So for example, 1 pointer pointing the first element in nums. So the range will be from the first one up to the middle. And then the second pointer will start from the first element in nums2 or the corresponding position in nums itself. Then we can do the iteration like here. And that will be O of 1. So you're welcome to implement that comment. So with that said, basically that's about it for this video. Thank you.